Okay, welcome to part 8, titled Taking a 30% Leap in Productivity. Now, I want to explain this in more detail, the productivity gains that are possible through mixed model manufacturing, since they can be huge and too big to be believed, really, unless we explain clearly how this can happen. So let's break it down and look at how a 30% productivity gain could be possible. Again, 30% is possible, but it could be more, it could be less. But it's big, so let's take a look at it. So productivity strategy number 1, standardization as a requirement. So the term we use for process documentation is a standard work definition. That's the term we use, or SWD. So documenting the one best way to do work at the product and the process level is a foundational requirement for mixed model manufacturing, or for any lean strategy for that matter. So the goal here is to document the detailed work steps, work times, quality checks, material requirements, tooling and fixtures, and so on, for every product and every process. So this is a big job if you don't have this already, but that's a requirement. So how does this impact productivity, you might ask? Well, in the process of standardizing, you can identify work steps as value-adding or non-value-adding and eliminate the non-value-adding steps. Remember this important point. A non-value-adding step can be eliminated quite easily because you don't have to make an engineering change to eliminate a non-value-adding step. Because by definition, it's non-value-adding. It doesn't affect the form, fit, or function of the product. So you can do this right away, or conduct process improvement work if that's needed as well. So when you take out non-value-adding work, productivity, of course, is going to go up. The percentage of value-adding time goes up. Okay, product strategy number 2. So designing optimum workflow. So if you record a workflow, document it, you'll probably notice that a certain percentage of the time the workers are not able to work. Well, why not? Well, typically it's for one of 2 reasons. They have nothing to work on, they have no work, in other words, or they finish their work, but they can't move the product out of their station. This can happen when you're trying to build products one at a time, sequential, like an assembly line environment. So, balancing the work better is how you reduce this waiting time, so that workers can add value more consistently and be more productive. So part of the balancing effort also includes the skillful use of buffers, or as we call them, in-process kanbans, as balancing tools. So that's number 2. Productivity strategy number 3, formal check-do-check practice. Now, obviously, having to redo work will detract from productivity. So one of the goals of your standard work definition is to analyze and improve quality risks. Remove them if you can. So this is called poka-yoke in lean speak, in lean language. But what about workmanship errors that you can't error-proof for one reason or another? Well, another technique which won't eliminate errors completely, but will help to catch them sooner, is called check-do-check. So that means check the work coming to you from upstream for quality issues. And then number 2, you do your own work. You do your work. And then, number 3, you check your own work. So just this simple practice can cause a boost in productivity by, number 1, sensitizing operators to when errors can occur, and number 2, catching the errors quickly rather than letting them proceed down the line where it's much more expensive to fix. Productivity strategy number 4, optimum sequencing plan. For mixed model manufacturing, optimum sequencing is a must. What that means is that since different models have different work content time, this variation will lead to increased starving and blocking of the workflow, which leads to lower productivity. So the optimum sequencing strategy is developed during the line design process based on product knowledge and often with the use of computer simulation tools if possible. Okay, productivity strategy number 5, optimum material flow, system and presentation. Now, productivity is going to drop like a rock, even with the best designed line in the world, if materials needed are not delivered on time with the right part to the right location, and operators will be waiting for needed material. Now, today companies are exploring the idea of strategic kitting to give a further boost to operator productivity by reducing the time and quality risk associated with part selection. So this whole issue of designing material flow, material delivery systems, huge topic, and in fact, the focus of a separate workshop that we teach, but hugely important for operator productivity as well. Okay, productivity strategy number 6. We're not done yet. Flexing as a way of life. Now, I saved the best for last here. The practice of flexing or moving to the work can be a huge productivity boost. So remember, even if you do everything right and apply strategies 1 to 5, as we just covered, a mixed model line still must deal with work content time and process variation. And this will always exist, and it can't be overcome completely. But if operators are willing and able, so important, 2 requirements, willing and able to move to where the work needs to be done, then they can continue to work and add value more consistently. And productivity will take a major jump up. And this flexing or moving is not freeform, but instead is based on a clear set of rules for when to move and when to stay and work where you are. So operators need to be trained in flexing, and it won't just happen by itself, or it won't just happen naturally or organically. Now, paying close attention to productivity and to a deep understanding of the factors that will hinder it is an important part of the mixed model line design method. Now, variability is the challenge, and by applying these 6 strategies, you'll do a lot to overcome it. And in those conditions, a 30% productivity gain is not merely far-fetched, it's perfectly achievable. See you next time.